In this video, I'm going to talk to you about how to use the Z value to determine the area under the normal curve. We're going to be using normal distribution tables, and that would be found in Appendix A.1 at the very back of your textbook. So make sure you can find those normal distribution tables. We're going to use these tables to determine the area under any normal distribution. Remember that normal distributions are symmetrical and that our normal distribution table provides the area for only half of the curve. That's the right half. But symmetry has a lot of benefits, so you'll recognize that when we do some of the calculations. So starting with this example, we're going to ask you to determine the area under the normal curve both to the left and to the right of the following Z values. And we will start off with Z is equal to 1.2. So find the tables and we'll draw a normal picture or a normal bell-shaped curve and locate the Z value because I want to talk to you about how to read the tables. The first one is Z is equal to 1.2. So we've got a normal curve. We know that for the standard normal distribution, the middle is at 0, and we've got a standard deviation of 1 for the standard normal distribution. And we want to know the area to the left and to the right of Z is equal to 1.2. So where is Z equal to 1.2? Well, let's see. We've got 1, 2, 3 standard deviations to the right, and -1, -2, and -3. The standard normal curve is between -3 and +3 standard deviations to the left and to the right of the middle. And for Z is equal to 1.2, we know that 1.2 is somewhere here. So Z is equal to 1.2 is on the positive side or to the right of the mean. So now we need to move to our A1 tables. Let's take a look at what they give us. So this is what the Appendix A1 tables look like, and you can see that the area under the normal curve is given between the value of Z is equal to 0 to the Z value. So these tables always give us the area to the right of the mean and the Z value. So you can see that what we have here on the A1 tables is that the Z value is along the left-hand column, but also we have a 1 decimal place to the left-hand column, and the second decimal place is in the columns that are above the top. So if I want to look up a Z value of 1.2, I'm going to scroll down this list until I get to a value of Z value of 1.2, and it's really 1.20. So that Z value is going to be 1.2 and 0 right along here. So that's 3849. 0.3849 is the area that I'm looking for. So let's mark that 0.3849 or highlight that somehow and go back and do our calculations. So for a Z value equal to 1.2, the area worked out to be 38.49%. Now, it's very important that you recognize that the area is between Z is equal to 0 and the Z value. So 38.49% is the area between the 0 point or the middle and the Z value. So if we're looking at the Z value of 1.2, then what do I know about the area that's to the left of Z value of 1.2? Well, I know that 50% is to the left of the middle, or 50% is to the left of 0, so therefore it's 50% plus the 38.49%. So the area to the left of Z is equal to 1.2 works out to be 50% plus 38.49%, and that works out to be equal to a value of 88.49%. And similarly, on the other side, that's the area to the right of Z is equal to 1.2. We can say that to the right of Z is equal to 1.2. How do we calculate that area that I've got highlighted in red? Well, 50% of the area is to the right of the middle, but we've taken away a chunk of 38.49%. So to the right it would be 50% minus 38.49%, and that works out to be a value of 11.51%. So we've got 88% that would be to the left, 88.49% to the left of the mean, and 11.51% to the right of that Z value. And what you'll notice also is that that adds up to 100%. In other words, 100% of the area under the area under the normal curve is 100%. Now let's determine the area to the left and right for the z value of negative 0.8. Well, if the z value is negative 0.8, what does that tell you? That tells you that the z value is to the left of the mean. So here is the z value of negative 0.8. So z is equal to negative 0.8 is to the left of the mean. And we'll go to our normal distribution tables, or table A1. So here's our table A1, and the A1 values give us only positive values of z, but it really doesn't matter because the normal distribution is symmetric about the mean. So 0.8 standard deviations to the right will be the same as 0.8 standard deviations to the left. So there is 0.8, and 0.80 corresponds to 28.81%, or 0.2881. I always convert them to percents because I find it easier to deal with percents. So we'll use 28.81% and record that. So we now know that the area between the mean and the z value is 28.81%. So what exactly do we know? We know that this area between 0 and negative 0.8, that small little sliver of an area is 28.81%. So what do I know about the area to the left of the z value of negative 0.8? Well, the total area to the left of of 0 is 50%. So if I take away the sliver, then I know that the area to the left of z is equal to negative 0.8 is going to be 50%. Take away the sliver of 28.81%. So that's going to equal a total area of 21.19%. So what that means is that the area that's in here will be 21.19%. And what's nice about the normal distribution is that you can always take a look at it and see if it makes any sense to you. And you can see here that I've got half of the area to the left of the middle, 28.81% plus 21.19%, certainly adds up to 50%. So this is great because now what I'm going to use is I'm going to use the 100% rule. I know that the total area under this curve is 100%. So therefore, the area that is to the right of that z value of negative 0.8 will be equal to 100% take away the 21.19%. So the area on the right-hand side of z is equal to negative 0.8 will be 100% take away 21.19%, or 78.81%. So the area to the right will be 78.81%. And 78% plus the 21% certainly adds up to 100%. So there's two ways that you could do this. The other way, of course, is to take the 50% that's to the right of the middle and add it to the 28.81% sliver, and that will give you the same total. Now in part C of this question, we're asked to determine the area to the left and right of z is equal to 2.75. Now z is equal to 2.75 is right around here. So 2.75, and you can see that there isn't much of an area to the right of it, and certainly there's a large amount of area to the left of it. So z is equal to 2.5 is on the right-hand side of the mean. Let's go right to our z tables, or table A.1. And here is table A.1, our normal distribution table, and you can see that I don't even have a z value of 2.7 just yet. I got to scroll down all the way to the bottom of the list here. So 2.7 is here, and now I have to go across to 2.75. So how do I find that? Well, I'm going to go back to the top here and say 2.75 is down this column. So it's down the 5 column, so stay in that column and read across 2.75. So the area that corresponds to a Z value of 2.75 worked out to be 49.7%. So what area is that? Well, that would mean that the area that's between the middle and the 2.75, so 49.7%. So what's the area that's to the left or to the right of that number? Well, that would be 50% takeaway. So on the right-hand side, we would have 50% take away 49.7%, which leaves us with a very small amount of area. That area that's greater than 2.75 standard deviations would be 0.3%. What about the area on the left-hand side of that Z value of 2.75? Well, that would be 50% plus the 49.7%. So on the right-hand side, we would have 50% plus the 49.7%, or a total of 99.7% of the area. Or alternately, you could just do 100%, take away the 0.3%, which is 99.7%. So 99.7% of the area is to the left of 2.75, and 0.3% of the area is to the right of 2.75. And for the last question, we need to find the area to the left and right of Z is equal to minus 1.95. So where is Z equal to negative 1.95? Well, that's not quite negative 2, so let's just say it's very close to negative 2. So there's our Z value of equal to negative 1.95. So how are we going to do this? Well, we need to go to our Z tables and look up the area for that Z value. And so what is the area for the Z value equal to? And so once again, we're back to our Z table. So I'm going to go down the list until I find 1.9. And remember that it's the same on positive side as it is on the negative side. So 1.9. And then I read across until I get to 1.95. And so there it is right here. It's 4744, 0.4744. So denote that and make a note of it, or circle it and go back to your notes. So what does this area of 47.44% tell you? It tells you that the area between the mean and the Z value of negative 1.99 is 47.44%. So what's the area to the right of that Z value of negative 1.99? Well, it would be 47.44 plus 50%. So on the right-hand side of that Z value of negative 1.79, we would have 47.44% plus 50%, which adds up to 97.44%. So we've got 97.44% to the right of negative 1.95. So if 97.44% is to the right, then certainly it's easy for us to figure out what's to the left of that Z value, and that would just be 100% of minus the 97%. So on the left-hand side, we would have 100% take away 97.44%, or 2.56%. So we would have 2.56% to the left of Z is equal to negative 1.95.